Hello, geometry folks. Today we're doing 12.3. This is probably my favorite section of geometry in chapter 12. My chapter 12 favorite right here. We are going to be talking about inscribed angles. And inscribed angles, by definition, it says the vertex is on the circle. Okay, inscribed angles have a vertex on the circle. What I mean by that is the vertex is a point in the circle, or a point not in, that sounds like you're going inside. It's a point of the circle. So point C right there would be our vertex. That is an inscribed angle. Okay, and then it's formed by two chords. So AC is a chord and BC is a chord. That gives us our inscribed angle. So this is our inscribed angle. Okay, and then you have what's called the intercepted arc, and the intercepted arc is the arc that those two chords create. Okay, so it's between the two chords that we are using to form our angle. Okay, so then we have this theorem. It's called the inscribed angle theorem, and it says the measure of an inscribed angle is half. So you can say half or 1/2, the measure of the intercepted arc. Okay, what that means is if we're looking at this picture, the measure of angle B, okay, this angle right here, will be half the measure of arc AC, which is right here. Okay, in other words, if I were to tell you that this was a 72-degree angle, then angle B is going to be half of that, and half of that would be 36 degrees. Okay, so that's the relationship, and we're just going to do a few problems using that relationship to show you what I'm talking about here. Oh, apparently I have a little box around that first one. Okay, so in this example, it says, what are the values of A and B? Well, where you have to look here is what do I know of angles and intercepted arcs? And I would probably start with angle B right here. If you look at angle B, okay, that's this angle. And that angle gives us an intercepted arc. The intercepted arc is where those chords end, what arc connects them. So if my arc is 56, then my angle, my intercepted angle, my inscribed angle, sorry, is going to be half of that. So angle B is going to be half of the arc. So half of 56. So that makes B 28 degrees. Okay, so I know angle B is 28 degrees. Then let's look at A, because A takes a little bit more work in solving, I would say. If you look here, we have this angle, and that's 52 degrees. A is part of the intercepted arc for that, but it's not the whole thing. If you look, okay, intercepted arc, that whole arc is related to this angle. So if the angle is 52, the angle is always half of the arc, so we would have to double it to get this arc. So that arc is going to be 104 degrees. Does that make sense? Hopefully. So if I know the arc is 104 and I know this piece of it is 56, that means 56 and A put together have to equal 104, so we're just going to take that 56 away. Okay, that leaves us with a value of A of 48 degrees. So arc A is 48 degrees. Okay, so just keep in mind when the point is on the circle, the angle formed at that point is half of the arc across from it. Okay? Okay, so then this one, what you're looking at is a whole bunch of angles and a whole bunch of arcs that go with them. So if I say find the measure of each inscribed angle, one inscribed angle right here would be angle A. okay? So let's just call this x for now. If I'm looking for the value of x, I want to find the intercepted arc, and my intercepted arc here is that. Okay, so ask yourself, how big is that arc? Well, that arc is 190 put together. So we would say angle A is half of that 190 put together. So half of 190. So the measure of angle A is going to be 95 degrees. Okay, so that's angle A. Now let's look at angle B. Angle B goes here and here, which means its intercepted arc for angle B is here. Okay, well that arc, which we would call arc AC, will help us find the measure of angle B. The measure of angle B is going to be half of whatever that arc is, and that arc is 64 plus 90. Okay, so half of 154 will be the measure of angle B, which means our measure of angle B is 77 degrees. Okay, on to angle C. Angle C, okay, so we're looking for, we'll call it Y here, we're looking for that angle measure. Well, the intercepted arc here is going to go from B all the way around to D. How big is that arc? We would say the measure of angle C is half of that arc, and that arc is 106 plus 64. So that's 170. So you're taking half of 170, which means the measure of angle C is 85 degrees. Okay, and then the last one, we're finding the measure of angle D. So here's angle D. Okay, the intercepted arc then goes from A all the way around to C. Okay, that means that the measure of angle D is going to be half of 106 plus 100. So half of 206, so the measure of angle D is going to be 103 degrees. Okay. Now here's what I want you to see, because this is coming right here. If you look at these, notice 95 and 85 and 77 and 103. What do you see about those? Those are angles that are across from each other, right? B and D, A and C are across from each other. And if you're paying attention, you'll see these two add up to 180 and these two add up to 180. Okay, that's a corollary to our inscribed angle theorem, which I will tell you about right now. All right, so here it is. There are three corollaries. Remember, a corollary is just an add-on. So more information that we know about this setup, okay, about the inscribed angle theorem. Here it is. The first one says, two inscribed angles that intercept the same arc are congruent. Okay, let me show you what I mean. Angle A, right here, has an intercepted arc right here. Okay, well now look at angle B. Oops, angle B goes here to here, and what is angle B's arc? Angle B's arc is the exact same arc. So if they have the same arc measure, then the angles have to be the same because it's half of the arc, right? So if they intersect the same arc, then we have the same angle measure. The angles will be congruent. Okay, so that's the first one. The second one, it says an angle inscribed in a semicircle. Oh, I'm still on my highlighter, is a right angle. Okay, think about that. If I have a semicircle, Okay, so this is a diameter, meaning this arc right here is 180, right? It's half of a circle. Well, my inscribed angle opens up to that arc. So if that's 180, the angle has to be half as much, so the angle would be 90. So whenever you see a semicircle, right, diameters are huge. Whenever you see a diameter, you know you have a 180-degree arc, which means if you have an angle inscribed in that, it's going to be 90. Okay, and then last one, number 3, it says the opposite angles of a quadrilateral inscribed in a circle are, and this is what I just showed you, they're supplementary. Okay, meaning if I have a quadrilateral here, which I do, my opposite angles, so if I said x and y, I know that x plus y is going to equal 180 every time if it's a quadrilateral inside of a circle. Okay, I also know that A and B, if I add those together, they will also add up to 180, which makes sense, right? Because a quadrilateral, all 4 of them, should add up to 360, which is what would happen here. Okay? Okay, so we're going to use those ideas and do 3 more problems, and then we're done. First one, it says solve for the measure of the numbered angle or angles for each of these problems. So the only one you have to find in this first one is this angle. What is the measure of angle 1? Well, there's a whole lot of information here that really doesn't matter to us. The only thing that really matters is this is a diameter, right? Goes through the center. It's a diameter, which means this is 180 degrees. Well, look at where angle 1 opens up to. It opens up to that arc from here to here, 180, which means the angle 1, is half of that 180-degree arc, which means angle 1 is going to be 90 degrees. Remember, it said if it opens up to a semicircle, it is a right angle. So we know angle 1 is a right angle. Okay, so that's the first one. That was corollary number 2 that we're referring to there. Second one, you have this picture. Again, only one piece of information. It might be tempting right here to say, oh, well, there's a 70-degree arc, so this must be a 70-degree angle, and forget angle 2. This is not the center of the circle, right? We can tell that's not the center. So just be careful that you don't try to go there. That's not what we're looking at. Think about what we do know. I have a 38-degree angle here. Well, if I open that up, okay, this angle is half of this arc. So if that's 38, double it, and the arc is 76. We're looking for this angle. And where does that angle open up to? Well, it opens up to the same arc. So if my arc is 76, then my angle is half of 76, or 38. Okay, but now here's the thing. You didn't have to do the work. You didn't have to do this part of it, because you saw that a 38 opens up here and angle 2 opens up to the same arc. If they open to the same arc, they are the same measure. Okay, so technically I don't need to see this, because once you see that this is 38, you know that that is 38 also. Okay, last one. And I feel like this is the one that people forget about the most. 2 things going on here. First of all, you have a diameter. So if this is a diameter, then let's look at angle 1. Angle 1 opens up to this arc, which is a semicircle. And if it opens up to a semicircle like that, it's half as much, or it's a right angle. So we would say the measure of angle 1 is 90 degrees. Okay, now look at the measure of angle 3. You can look at it that same way. Angle 3 opens up here and here to a semicircle. So 180 cut in half is going to be 90. Or we know that opposite angles for a quadrilateral inside of a circle, opposite angles are supplementary. So if this one is 90, then this one has to be 90 also to add up to 180. Okay, sometimes this can be a little confusing because yes, those are congruent, but are these congruent? No, you can obviously see that those are not the same size, right? So just be careful you're not setting these equal, you're setting them equal to 180, okay? Okay, then angle 2. Actually, let's go to angle 4. Do you see why I want to go to angle 4 first? If you look, angle 4 opens up here to here, which means it's this arc, okay? So we would say the measure of angle 4 is going to be 60 plus 80 cut in half. So half of 60 plus 80, or half of 140. So the measure of angle 4 is 70 degrees. Okay, so now here's the thing. If this is 70, we know these two are supplementary. So we can say the measure of angle 2 is 180 minus 70, or 110 degrees. Okay, so the measure of angle 2 would be 110. Do you see another way you could do that? Let me show you something. I know that this is 140. That means I know the rest of it has to add up to 360 to make a full circle. So I could find this arc, and then I would just have to cut that in half to get my angle. So this arc comes out to 220. I'm not sure why it doesn't want to write that. If we cut 220 in half, we get 110. Okay, so you have a couple options with how you want to go about that one. All right, that is the first half of 11.3. We will do 11.3b tomorrow. Sorry, 12.3b tomorrow.